Hello and welcome for our December webinar. We're going to be talking about the Deep Pit Barn Challenge for anaerobic digesters, and I am extremely pleased to present today's speaker, distinguished professor Dr. Robert Burns over at the University of Tennessee. He spent part of his career here at Iowa State in the position that I am lucky enough to now hold, and he is extremely knowledgeable about anaerobic digesters, got me started to understand what they do and how they work. So I think it's a great honor and privilege to get to hear from him on some of the challenges that he's been thinking about for a while now and what maybe some of the opportunities might be. With that, he's done a lot of digester work both here in the United States and abroad in Europe. So comes with a vast array of experience and knowledge on both practical challenges of digesters and then integrating them into manure systems. So thank you so much for joining us, Dr. Robert Burns.
Thank you, Dr. Anderson. Appreciate the very kind introduction. And as you indicated, I'll visit today with the group about deep pit barns and the challenges we have when we try to use that manure and anaerobic digesters. Um, give you a outline of my presentation, and I'll start by telling you that I don't have any good solutions to share with you. Um, I hope I'll share some things that'll help us all think together about how we could come up with some better ideas. I had a supervisor one time that told me I should never bring him a problem unless I had a solution to it. I'm not real sure how good that advice was, but I'll tell you today that I'm going to violate it. I don't have a good solution. This is an anaerobic digestion group, so probably don't need a lot of background, but I'm going to touch just very briefly on, why do we look at AD of swine manure, the type of systems that we basically use, but I'm not going to go into any real depth on either one of these because I really want to spend our time today talking about deep pit swine manure management systems and the challenges that we face in how do we frequently remove fresh manure from those systems, and then after we digest that manure, where do we store it? Um, and then talk about some ideas for frequent manure removal. And then I want to try to hold enough time that we can open it up for this group to discuss ideas and talk. If is that possible to do, Dan? Can we open it up for folks to?
Absolutely. I think at the end, Melissa will open everyone's mic and we'll have a chance to have a discussion about it.
Okay, super. I'm pushing forward, but not going forward. Let me. There we go. Okay, so swine manure anaerobic digestion, basic stuff. We're have had an interest in manure digestion for many years. Go back and look at the old AgStar program, and we started with plug flow dairy digesters, and then moved on with swine digesters. Most of the swine digesters that we actually collected biogas on, I first came in contact with in Europe, working in Germany, and that industry grew very well because it was subsidized. And so the basic model there was to take about 50% swine manure and about 50% corn silage because that was allowed, and that that addition made a good feedstock because the manure provided strong ammonia buffering. The corn silage made a lot of biogas, and that was the system. In in this country, we've used anaerobic treatment lagoons for many years on swine farms, but often they were not covered. With the interest in reducing greenhouse gas emissions, there's been a renewed interest in anaerobic digestion from since we collect that gas, and also because of the RIN market and uh, and the CARB market for renewable fuels, there's been a renewed interest in taking that gas, cleaning it to pipeline quality, pressurizing it, injecting it. Most of the systems that I originally worked on were reciprocating engine gensets where we made electricity. But we've seen a market for renewable energy that sparked renewed interest in anaerobic digestion. So there are many different types of digesters. We could talk about, again, plug flows and ASBRs and all kinds of different things. But for swine, today I'm just going to say there's two primary types you're going to run into. These covered anaerobic treatment lagoons, where we're now very interested in trying to collect that gas and generate a revenue stream from it, as well as not only the gas value, but the carbon credits that we can generate from collecting it as well. And then purpose-built tank digesters. These are typically continuously stirred tank digesters. And here's a couple of shots of some of European type digesters that you'll see in this country as well. But this was pretty standard fare in Germany and throughout Europe for swine manure. And so we have to get that manure from the barns, the swine manure, into the lagoons. This is a picture of an uncovered lagoon. It's an anaerobic treatment lagoon, but just the point here is we would typically gravity feed. So these are our shallow pit pull plugs. We pull the plug, we gravity feed that manure into our system. And that's how we would really like to feed our digesters if we can, because anywhere we can eliminate pumping, it's a good thing. Keep it as simple and functional as possible. Uh, and shallow pit recharge systems typically work well for that. We can pull a plug, we can do a gravity drain, if not directly to the digester, to a sump or collection pit that we can pick it up and move it. And these systems work well for that. You get into an issue of, we'll talk about as we go a little farther on, well, we want fresh manure as possible. So there can be some discussion about how often we pull that plug. And again, we'll touch on that when we get there. But what we came to talk about today are deep pit barns, because most of the barns, um, majority of the barns that we have finished pigs in this country are deep pit barns, especially throughout the Midwest. So the manure falls through slats just like it would in a shallow pit pull plug, but we go into an under barn storage that's designed to hold that manure typically for a year, where that is our manure storage. And we're not set up to gravity drain from these systems. In fact, we want them to be completely watertight. We want that manure to stay in that pit and go nowhere else. And then we're going to pump it out and use it for fertilizer in our appropriate land application windows. So these systems they were not designed with the thought of frequent manure removal in mind. But if we want to feed an anaerobic digester, we obviously want to feed it more than once a year, and we want to feed it fresh manure. So those are our challenges. How are we going to frequently remove fresh manure from this deep pit system? And then we also have to think about, where is our storage? And this is problematic for us, because if we were to take that digested manure, which is now um, had its ability to produce gas removed in essence, because we went through the anaerobic digestion process with it, we don't want to put that manure and mix it back in with our fresh manure. That digestate needs to remain separate, but it also has to be stored, because anaerobic digestion is a I like to call it a nutrient neutral process, because the obligate requirement of nutrients by the anaerobic bacteria is so small. It's not of importance in this process. The nutrients are still there. We're going to move those nutrients in form. We're going to mineralize some nutrients to make them more plant available, but the nutrients still have to be stored. The manure still has to be stored until we can land apply it. So now we've got to have somewhere to store it that is not mixed with our fresh manure that we want to separate and remove frequently. So if you use manure as a digester feedstock, and I should uh, mention here that manure is typically not our only digester feedstock. As I mentioned earlier, we're going to co-digest with other materials, but that's not the point of today's discussion. So I'm just going to talk about manure as a feedstock. These digesters are typically fed daily, um, and we maximize biogas production with fresh manure. So manure age very much impacts the methane production potential of that manure as an anaerobic digestion feedstock. Um, and I think to learn more about this, there's a paper by Dr. Anderson that I would recommend you go read if you hadn't, um, that did a lab essay for estimating methane emissions from deep pit manure storages. It's a really good paper, and you can You can show a graph of how this reduction changes by day, but the take-home message here is the fresher the better. In this paper, the authors estimated a 46% reduction in methane emissions by removing manure twice a year from a deep pit as compared to just once a year. So just take it out every 6 months, and we essentially cut those methane emissions in half. Now, what that means by cutting those methane emissions in half, that means that methane potential is still in that manure, and if we put it in a digester, we can generate that methane in the digester and collect it. But we don't want to collect every 6 months. Ideally, we'd collect fresh manure every day. But the thing to think about, if you collect it every day or every other day or every week or even every month, you're still going to produce biogas. It's just you're going to produce less the older that manure is. So our goal is to collect fresh manure as frequently as possible to feed our digester. So now let's start thinking about our traditional swine deep pit barns. So if you do the math on a 1,200 head finished floor with the typical dimensions, and assume that on average a hog's going to create 1.3 gallons of wastewater a day, that works out to about a quarter of an inch of manure depth a day being added to that pit. Now, these are fast and loose numbers, because you know that when we put um, nursery size pigs in and we grow them up to a finished weight, that depth increase is going to be less at the beginning of the grow out and much more at the end. But just to think about it in terms of how are we going to remove this manure, we're talking about on average a quarter inch a day. And we also know that when we pump this pit out, we don't completely empty it in our traditional pit setup. This picture at the right is of a very full pit that needs to be pumped. We've pulled the fan outlet off, so we're ready to do so. So we've got 8 feet of manure in essence. This one's really full up to the plenum, but we're only accumulating a quarter of an inch a day on average, sometimes less, sometimes more. So depending on the pump set and how we do it, we're probably going to leave at least a foot, maybe more like 2 feet of manure in the bottom of that pit after we pump it out. Again, it depends on what type of pump we're using and basically how close we can get the intake to the floor, the volute to pick up, and how much we're going to leave. Now, thinking about that, if we say, okay, let's think about a 2 week period, we'll put in on average 3.5 inches of fresh manure. But if we add that 3.5 inches to 24 inches of old manure, um, we can never achieve fresh manure, right? I've sat down and pushed the pencil on this to how long does it take until it's all fresh manure? Well, you can't get there because time continues to make your fresh manure old manure. Um, in the whiskey production business, they call this the Solera method, and they some distilleries are very proud of it because they say that they keep their whiskeys are consistent. They always taste the same, right? They use a big vat and they never let the vat go empty. You're always putting new whiskey with old whiskey to marry them. And that's a good thing in the whiskey business, but in the manure business, it's a bad thing because we don't want to marry our fresh manure with our old manure that's lost its methane production potential. So that's the challenge in a nutshell. How do we take a pit designed for annual storage that's getting um, a few inches of manure every couple of weeks added to it, and that's what we want. That fresh manure that's being added. We don't want the old manure, and we want to remove it frequently. So let's think about how can we solve this problem. And I'm going to talk first about what we really aren't interested in, right? Let's go build a new barn. But I think by talking about how we might build new barns to do this, it at least helps me to think about how I might modify an existing barn to be able to pull this off. And lots of different options, but I'll throw three out that that I've seen and probably you've seen as well. Shallow pit pull plugs, which we already discussed, underfloor scrapers, and then shallow channel overflows, which you may or may not be familiar with, but we'll touch on them. So shallow pit recharge. These are pull plug barns. They work. The issue that you get into is with the farm managers is how often you're going to pull the plug, because typically you pull these plugs in the US every 2 weeks. And if you start wanting to pull them more frequently than that, the barn managers will probably not be agreeable to that in my experience. But it gives us the opportunity typically to gravity drain because that's how they were designed to begin with. Um, Works well. You've just got to get that manure out frequently. These systems have slatted, or they have, excuse me, slope floors. We've got a slope on the floor, and we usually put some charge water in before we begin, so the manure that falls through the slats doesn't stick. But that slope allows us to pull and drain. If we take a look at underfloor scrape systems, so there was a lot of research done on these systems back. It's been a long time ago now when folks really first began to get concerned about ammonia emissions in this country. And a lot of systems, Michigan State did work, Bob von Bernuth there. They looked at systems to separate urine and feces. So there's a lot of different modifications to the scrape system. This one is just a basic diagram of a flat scrape. The urine and feces separators had V's on slopes, but the basic idea is we're going to scrape this manure into a collection sump and then we're going to pull it out. So again, this can be done very frequently. Um, these are really not caught on in a big way, and in my opinion, it's because they've got a lot of moving parts, right? For those of you that have worked in manure, especially in dairies, we see a lot of scrapers, but scrapers and mechanical things in manure have a hard life and require a lot of maintenance, and it's probably not a very exciting prospect to put this in the bottom of a pit and have to deal with it. This is a top view of a shallow channel overflow system, and I'll be interested to see if y'all have seen these type systems or not. This is basically a modified European shallow pit pull plug. This particular picture here shows a digester on the left. Was one of the first ones that I was involved in helping build in Europe in Gradec, Croatia. The guy that actually was the mastermind behind it, Dr. Robert Speich. Dr. Anderson knows well. Dr. Speich was in my team at ISU at the same time Dan was there, and they worked together. But this is the first one that he built. We built a 1 megawatt facility. It took some 6 different substrate, and this is a picture of it on the left. 6 different substrates. Only one of those was swine manure. So they had spent brewer's yeast, they had cheese whey, they had slaughterhouse waste, they had corn silage, they had waste food. They had a lot of stuff that we could put in it and worked very well. At Gradec, the reason it was built there is there was a 2,200 head sow facility there that we were using the manure as the digestion base for. Those barns were pull plug barns. We expanded this to a 2 megawatt digester, basically mirrored the facility and built a second one with it. And we added 14,000 finished pigs at this location. And when we did this, this is a shot of those barns being built here on the right. And when I say overflow, we took their pull plug systems, the Europeans, what the Croats use anyway, are double channels. You can see them open at the end, and then they have dual plugs. And by pulling these plugs together, they think they create a system that causes some um, stirring in the pits that causes them to clean better. They're sloped at a 0.5% slope, and the sow barns I mentioned, we could never get the managers to agree to pull them more frequently than once per month, which is a long time. But the reason they didn't want to, they did create enough of a disturbance in these pits when they pulled the plugs that ammonia emissions would rise. They'd get ammonia in the buildings because the pits are not ventilated. So the way we got around this with the new finish barns is there are no plugs. We put 15-centimeter vertical standpipes at each of these white circles you see here. And so basically these 14,000 head finish floors overflow all the time, right? They're continually weeping manure out that then is gravity drained and goes to the Gradec digester. Uh, and and the managers don't have any quarrel with it of the swine buildings, and we have um, fresh manure. And we can argue about how fresh it is because that the 15-inch standpipe or 15 centimeter, excuse me, about 6 inches why do we put a standpipe in at all? And the reason is because of that slope floor. We want to keep that floor wet all the way to the other end so we don't have manure that falls on it and dries and crusts and sticks. So basically 15 centimeters is the height it takes to keep that floor wet to bring it level back to the end, the shallow end of the pit. So we always have a wet floor, and we let them continually overflow and then gravity drain into the collection sump. Because at this digester we've got a large a large collection vat, if you will, where we pre-mix all these substrates together before we feed the digester, and again feed it daily. It's their CSTR systems, a pair of CSTRs. So those are some ideas if you're willing to go build a new barn, but we really don't want to go build new barns, right? The whole idea is we want to couple anaerobic digestion with our existing deep pit barns. And this is where I come up short on good solutions, but I'm going to throw two ideas out to you here to talk about. One is what we'll call a mass flow agitation system, which you've likely seen, depending on what part of Iowa you may be in, for those of you in Iowa. And then the idea just simply to put a collection sump on our deep pit barns that already exist. So the mass flow system, mass agitation system that I'm familiar with is done by Puck Enterprises in Manning, Iowa. And basically, this picture on the right probably explains it the best. They'll go into a barn and put piping in, and they pump manure through that piping such that you're using velocity to lift and entrain solids. So we're going to take a large pump capacity and pump. You can see the small pipes coming off the end. The idea is to to push manure jets out those pipes with enough velocity that we stir those solids up out of the bottom of that pit, and then we lift it through these red suction pipes to pump it out. Now, this system was not designed for frequent manure removal. They designed this system to try to get those solids out of these deep pits because, if you take a hool pumping agitator like I showed you in one of those earlier pictures, or pick your favorite flavor of vertical pumping agitator that we drop in one of these pits, its zone of influence is limited, right? We're going to pick up solids right around that pump where that intake is, but out, if you've ever pumped one down and then looked in it, you're going to see mountains of solids everywhere else where they've been drained and left. So the idea that the pump company had was to entrain these solids with velocity, pick them up and get them out of there. Now, it's got utility for what we're trying to do on frequent manure removal, because with this system, um, the way that the suction pipes are set up, we're not actually putting the pump in the pit. We've got the pump up on a truck and a suction pipe going down. We can clean this pit out to a much lower level. We can leave 6 or 8 inches of liquid in it as opposed to 1 or 2 feet. So that gets us less residual manure to have to deal with. But it also means we've got to have that pump system there, right? Now, this becomes problematic. So if we think about going back and feeding our digester daily, well, at a quarter of an inch a day, we're not going to pump enough manure from a single barn daily to get the job done. But we are going to have more than one barn, right? So think about that. If we've got 8 barns or 16 barns or however many barns, we're going to pull from a different barn every day and keep rotating, such that we're maybe coming back to one barn every 2 weeks and pulling that 3.5 inches that I mentioned. The challenge here is, because this pump is a large pump and it's expensive cost, now we've got to move it barn to barn, right? We've got to make that investment and we've got to move it around. So it's by no means a perfect answer. The other challenge is the installation of this system. It's real straightforward. It's basically piping. It's straightforward to install in a new barn facility. But if you have an existing barn, it's problematic because now we have, before it can be installed, that pit's got to be cleaned. All those manure solids have to be removed, and that gets very complex because now you've got a hazardous space issue. So you're talking about um, you know people with hazmat suits that have breathing capability that are down there basically um, removing manure. So it's very expensive to do the cleanup. It's not very hard to do the install in a new barn. So challenges with that idea. The other idea that and I should back up and say I think at last count maybe there's 150 of these systems that have been installed in Iowa, some number like that. So this is people are actually putting these in new barns. You can go see these work. Um, this idea, to my knowledge, has not been done. But say, okay, we've got a deep pit, we've got the money invested there, so let's go in and let's put a sump in. Let's put a collection sump in and put a drain in the bottom of that deep pit. And again, we could do the same kind of deal. We could put a standpipe at at some minimal height just to keep the floor wet and basically turn this thing into, instead of a shallow channel overflow, we turned it into a deep pit overflow and we let it sit there and continually weep. Now, ideally, we would only build one sump and we would route pipe out and have several barns that go into a collection sump. But for simplicity, I've shown it on one barn. But this is not trivial because now we have to do an excavation. We've got to get down, deeper than our deep pit, which is already sunk 8 feet in the ground. Um, we've got to go in and we've got to penetrate that concrete. We've got to put our drain line in, and then we've got to even go deeper than that to put a collection sump in. And now from that collection sump, we've got to have piping and agitation set up and so forth to lift out of that sump to feed our digester or at least transfer the manure to our digester collection pit. But another idea on how we could possibly retrofit these. This one doesn't require existing pit clean out. It it doesn't require us to modify the pit other than putting that drain line in, but it does require a significant amount of excavation, of pumping, agitation, and pipe work to be done. Again, I think there's some economies of scale that can be achieved if we, can share one sump between 8 barns or whatever is sensible that we could reach with the lines. But there's an idea to think about. And once we come up with a scheme to get our fresh manure out, we've only halfway there. Don't forget, we still have to put the digestate somewhere. And this is quite problematic. If we think about our animal waste management system and remember that this digester is basically just removing a little carbon from the system to make biogas, um, it's basically just a unit process that we've put between collection and storage of our manure, and the rest of the system's unchanged. We're still going to have to utilize that manure, typically through land application. The nutrients are still there. So we've added a unit process, but we still must store. To return that manure back to the pit creates a problem because we want to collect that fresh manure from the pit. Um, and I, I have, and I'm sure I'm not alone, have set and have tried to come up with schemes of, well, we've got all these pits there. How do we use one of them? We sacrifice one for storage, and there's a lot of thought could be put into that, and there may be a way to do it, but it's not appeared itself to me yet on how do we get enough storage for all of the barns that are there without mixing old manure and new manure. But that's the challenge. Where does the storage come from? And so to recap, the big three challenges, at least that I see, there may be others, but frequent removal. How do we remove small amounts of manure um, on a daily or weekly basis? Again, I think 2 weeks would be fine. As I told you at Gratis, they're removing monthly on those sow barns. Now, we know monthly is not ideal, but it still makes gas. We'd like to remove more than monthly. We'd like to be, you know, uh, weekly, daily, maybe 2 weeks at the most, but it depends on um, what you can stand in terms of biogas production loss. But we want to remove frequently. We want that manure to be fresh as possible, and we have to have somewhere to store that digestate. So I've set the problem up. I've offered no real viable solution, and I would love to have a discussion about how we could come up with one.
Perfect. Thank you so much, Dr. Burns. I did get a few questions for you, but at this time I am going to ask Melissa to try and turn on everyone's mic. So if you'd prefer to ask your question yourself, your mic should become usable in just a second. But while we're doing that, we're going to try and maybe handle a few of the questions that came across. So the first one was, can you talk about some of the air quality differences or ammonia volatilization or hydrogen sulfide risk differences with flush, shallow pit recharge or scrape systems?
In my experience, with shallow pit systems, we see elevated ammonia levels in the house um, when we pull plugs. But personally, I've never seen dangerous levels produced from pulling a shallow pit plug. Um, the the issues I've seen that are problematic, truly problematic, have been when we go into deep pits and we agitate those deep pits, and it's we can get microburst of um, hydrogen sulfide is what I've experienced. Where um, worked with one producer that had the same company pump his deep pit barns for 10 years and had never lost a hog. And then one year they lost hundreds of top hogs, died in a circular pattern out from around one corner of the barn. So they'd had a microburst of H2S. Um, why the conditions were right that year and it caused it and it had not before was unclear, but it did. I have not seen those types of levels occur in shallow pit systems. Um, and I'll also mention that I've seen two types of shallow pit systems. I have seen them with ventilated plenums, and I've seen them without, although it's probably more common the ones that I've seen were without. I know those that are in Europe that I mentioned are without, and that's the answer to. We had that discussion with the managers, right? We want to pull the plugs every week. They said, nope, we're not having ammonia generated rise every week on our pigs. Um, and the answer would have been to ventilate the plenums. But so you will see ammonia increases, but not at hazardous levels to the pigs or animals in the shallow pits.
And generally, all those systems will probably have lower ammonia emissions than deep pit barns in general.
Yes,
Yeah.
I absolutely right. There's a reason that every deep pit barn has got four fans in the bottom of it,
Mhm.
and that's because the gas generated in those deep pits would cause us real production problems if they were to go up through the slats. And the reason that most shallow pits are not ventilated is because they don't generate those amounts of gas. I don't have real world experience with scrape systems, but I would expect that they would be much more like shallow pit pull plug systems than they would deep pit systems.
Mhm. And then we had a question, could you not just make the pit the digester? And I think there's some real challenges with that, but let's talk about them.
Yeah, so that's a great question. I had the slide in this set and I took it out. You'll remember it, Dan, when in about 2008 when we started having flash fires and barn explosions, we Ross Mobile actually got to one of those that had not exploded, but I've got this beautiful picture of the entire pit on fire underneath the slats. It's just amazing. And so, you know, for a long time, a lot of people, certainly myself included, made a bad assumption. The train of the school of anaerobic digestion that I'd come from said if you have too high of an organic loading rate in your digester, you're going to inhibit digestion. And I think a lot of us, myself included, assumed the organic loading rate in a deep pit was so high that methane production would be minimal. And then when we started having barns explode and trying to figure out what it was, and it was tied to foaming, that foam was actually holding gas. And we got to those barns as that started happening and started sampling gas, and we had samples coming back from the gas entrained in that foam that was 74% methane. And so said, well, aha, these deep pits are making far more methane than we thought they were. Now, are they making as much methane as they would if they were a design digester that's loaded in a design range and so forth? Probably not, but they're making lots of methane. So that's the challenge. And when I say the challenge, and I spent a lot of time sitting around drawing different schemes for um, systems that were shaped like this to collect manure, slide it into the pit, right? Because what you want to have is you want to let the manure get into that pit, but then you've got to have a gas barrier, right? Because you can't let those gases, we don't want those gases to go back up into the barn. So that's the challenge. How do we collect the manure into the system and not release the biogas from the system that we're going to create for both the concerns of explosion concerns and the fact that we're after the biogas, right? That's our revenue generator to produce that renewable energy.
Perfect. Yeah. I mean, it seems easy. We've done it with lagoons. Go put a cover on it, and trying to get manure to fall in a natural way in a deep pit and do that. No one's found a good solution yet. And then a question that I have that I think is interesting and fun for you. So when the deep pit is emptied, has anyone tried thinking about additives to put into it? Let's say biochar or some sort of inhibitor to make it so I don't need to get the manure out maybe as quickly and still have the gas production.
Yeah, so a great question. And in fact, Dan's done some work on this. Dr. Anderson's done papers on it. I've done some papers on it. And I did one a long time ago looking at dairy manure. I think Dr. Anderson's done it more recently looking with swine manure. But basically, there's a lot of different inhibitors out there, but you can take compounds like rumensin. I think the trade name, monensin, rumensin. One's the trade name, one's the active name that's typically fed to cattle, and it inhibits biogas production in the rumen. And you can you can add that material to manures and it will inhibit gas production. And in fact, if you're feeding that material to an animal, the manure from that animal will inhibit gas production. And that's in the papers, the work that I did. We took manure from cattle that had been fed rumensin and looked at it. I think Dan took rumensin and added it to swine
Mm.
manure, if I remember correctly. And what you find out is that 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 inhibition that it causes doesn't last forever. So maybe you inhibit production for 20 days or 30 days or something like that. And the other thing you find though is that um, I guess two messages I'd say. One is that eventually anaerobic digestion systems are one of their strengths is that they can acclimate to things. So you could and basically the dose makes the poison, right? So if you'll introduce something to a digester, an anaerobic digester that's toxic, if you'll introduce it at a low enough rate, you can get that digester to acclimate to that and to stand it, as compared to say an aerobic system, right? If you put a little bit of quaternary ammonia in an aerobic system, it's over and done. But you could start feeding quats to an anaerobic system and acclimate it to it. Same thing with rumensin. So how long is that impact, that inhibition going to last? Because the system will acclimate it to it. But I think the bigger issue is in the work that Dr. Anderson did. You find out it's just simply cost prohibitive. These inhibitors, these additives are so expensive that it's a false economy. Now, I've not done work with biochar. I don't know if that's something you can address, Dr. Anderson. I have not tried that.
Yeah, I don't know that I would try it with biochar either. I think one of the things we've seen with biochar is that when you add it to manure, it often increases methane production, and that might be due to absorbing ammonia in the manure, so getting rid of potentially ammonia toxicity issues or helping it come along. And the other thing where I've really had some success actually is trying to get bacteria, methanogens, to grow on the biochar, and you sort of have a richer inoculum source, and that's probably what we want to avoid to keep the manure fresh. So
Right.
I understand what he's implying with biochar. It is really good at absorbing some carbon material and holding on to it, so it wouldn't be hopefully as bioavailable. I've had better luck growing bacteria on it and probably increasing methane production from that. The other part of that one that would be fun is if you would say I was going to throw rumensin in, great, it has some hold time. It's also going to have some hold time in your digester until you break it down or overcome inhibition. So you need to sort of balance saving the methane on the front end and making your digester function on the back end. All right, we have another question. This one's from former grad student of mine, Jake Wilsey, and he asked, Have you thought any more about the manure Roomba or a vacuum idea or any progress on that?
So, so the Roomba idea is and what he's referring to is we had an idea to um, put a robot system into a pit to collect manure, right? And my wife got a vacuum cleaner that drives itself around the house. It's very, very interesting. In fact, it's learn a lot watching this thing. And of course, now there's companies that are doing this in dairies. I've seen them selling these manure robots in dairies, and it's not, you don't have to think real hard to think, well, gosh, why don't we put one of those in a deep pit and just vacuum this manure out just like we would in a dairy alley vacuum. We did write a proposal, a grant that we put in on it, and it died. I don't think it made the first cut on the group that it went into. It wasn't didn't seem. I think the group thought it was too trivial of an idea, but in reality, it's not trivial at all because um, if you think about what are there 112, 115 posts in a typical deep pit system, so you've got post everywhere. You're submerged in manure, and that matters because some of the tricks that these robotic systems use to locate themselves and do travel path and so forth won't work when you're submerged in manure. So you're dark, you're wet, you're caustic. You've got 112 columns. You've got to have power tethered to this thing. I think now you could do it with battery if you look at we looked at battery systems and the battery life just wasn't there. And a lot of these dairy systems, the big ones, of course, are tanks. The small ones, the robot ones, actually fill with manure and go back somewhere and empty it, just like the little vacuum cleaner in my house does. But how do you do that down in this deep pit? So our idea was to tether power to it and to tether a line to it. So we're basically just down there pumping and pushing it up. And to answer the question, we've not carried it any farther, but that idea, if we could overcome all these problems, right, it would allow us to not modify our barns. Now, we'd have to move this thing from barn to barn, and the other thing about this is, well, we obviously don't want to be submerged all the time, right? When we first pump this thing out and then we drop the Roomba in, um, it may be over its head if we got 2 feet. So that was one of our goals was to be able to do the final cleanup after we'd pumped down with it. But now you're talking about running this rascal on a regular basis within this barn. And that becomes problematic from a cost standpoint because at some point you got to say, well, I've got to have one of these for every one of my deep pits, right? Unless I'm going to try to drag this thing out and move it from barn to barn. Now, and if you really want to get people hot and bothered, start talking about moving something from barn to barn from a biosecurity standpoint. The so that's a dead serious issue. I don't. You guys are probably following this, but last week African swine fever was found in Spain, which is really, I follow Spain closely because Spain is the country we need to pay attention to in the European Union that can grow pigs as well as we do. They're integrated in the same manner that we are. They're set up like we are. They're running PIC bloodlines, and they carry the mail on production numbers. And they had African swine fever 29 years ago that came in from Portugal, and they don't have it in the commercial herds yet. They found wild pigs dead with it, but that's an aside to say we've got to anything we come up with the whole idea of moving stuff from one barn to another is problematic. I think from a biosecurity standpoint, it's got to be a system that's low cost enough. We leave it in the barn. Perhaps the pump head, right? We may be able to move the pump head around, but we've got to always keep biosecurity in mind.
Perfect. And then we have two more questions, and if anyone who wants to ask a question by unmuting, you should have that ability now. I'm going to take the easy question here. Paul asks us how many grams per liter of nitrogen are in pig manure. And the answer, of course, is it depends, but I think a typical range in Iowa I might expect would be somewhere from around 1 to 10, and our deep pit barns tend to average 7 grams per liter. Uh, which is relatively high compared to something like dairy manure. And then he also asked a question on how have digesters penciled out for pig farms, and do they typically use all the electricity generated on site, or are they trying to sell an offset cost?
So, and I want to go back to your first one, Dan, and ask you that 7 grams. Is that total Keldol? Is that
That'd be total
DK?
Keldol.
Okay,
Yep, that'd be
yeah,
total Keldol.
okay. And then on the second question, you want to take it or you want me to take it?
I can probably take it if you want. So I think digesters, especially on deep pit farms, we haven't seen anyone putting in digesters on deep pit farms. That's one of the reasons we wanted to talk about it today. It's the elephant in the room, right? That's what we have in Iowa, and it's a really hard system to make work. The digesters that we've seen more recently on pig farms, as Dr. Burns said, have been covered anaerobic lagoons where they're already moving the manure out, and all they had to do was add a cover on the lagoon, and they make natural gas generally, relying on the RIN and carb market to become cost affordable. If we look a little further back than that, where people were making electricity, or the European model where people have been making electricity, we're still probably reliant on some carbon credits or a renewable energy credit many times. And they did tend to try and sell electricity when they were doing that, but taking co-products to do that. And Brian Seavers there, who runs a beef farm over in eastern Iowa, can talk to you about his specific facility and some of the things Raceline has been doing to try and make some of these a little more cost effective. And then this sounds like a perfect one for you. Experience on co-digesting swine manure with poultry litter.
I have none. Um,
Well, I have good news on that. We have a speaker who agreed to be on our next season's Emerging Science of Anaerobic Digestion. I'm blanking on her name. She's from Maryland. Stephanie Lansing. We'll be talking about that. And she tried to do digestion of poultry litters in various forms and fashions, often mixing with other things. So next year, we will have a speaker dedicated to poultry litter. I think my comment on it is it's sometimes challenging. We worry a little bit about ammonia toxicity with swine manure. Adding something high with poultry litter, often being high in ammonia, you run into some challenges with that sometimes. And then materials handling can be
yeah. Now,
not the easiest.
I have experience in poultry digestion systems, but
Mm.
never co-digested with swine. And I worked in China and saw a very large digester system. It was broiler chickens of all things, but they were collecting manure on belts like you would layer systems in this country and digesting it. And they had exactly the problems that you mentioned. They had ammonia toxicity issue, and then they had a tremendous issue with grit because the chickens had to be fed grit for their craws, and that grit wound up in the system. They collected loads of grit in their sumps that they were always fighting.
All right. If anyone online has a question they'd like to ask, now's your last chance to come off mute.
While you're looking for questions, I'll go back and mention on the question about electricity use in swine barns and in the European systems, all of those that I've worked with directly in Croatia, we're running Jenbacher gensets. We've got 8 digester systems running there now that are each 2 megawatts. We have 2 1 megawatt Jenbachers running at each one, and we make far more power than the farms can use. Now, it's not a straight comparison because I mentioned we're co-digesting other substrates, but in fact, we never did any direct use at all. We never used any of the power produced on the farms, and that was primarily because we were paying far less for the power we bought, and we had a subsidized deal where we were getting 19 euro cents a kilowatt hour. So we wanted every kilowatt we made to go and get 19 cents, and then the power to run the farm we'd buy back at a far lower rate. But Dan and I did a paper, a study not that long ago, last year before, I don't remember. And if you look at the cost to produce electricity, it's going to run somewhere around a quarter a kilowatt and through a manure digestion system. And again, it depends on if it's a very basic system or a more complex system. But the bottom line story is unless you're subsidized, you can't do it. You'll lose money.
Perfect. I'm going to let you handle one more question, but I'm going to advertise a little first. So, I have a newsletter for anaerobic digestion. If you sign up. You will be alerted for next year's season. We are going to take January and February off and resume in March. Most of these, I have a lot of manure meetings around the state of Iowa to do in January and February, and have trouble being in multiple places at once. Uh, we have a question on thinking about diets, and diets are increasingly precise. How does that affect the production capacity of a digester? What's happening there? Any thoughts?
I think that diet changes absolutely will impact that capacity. And I go back to the what I was telling you about when we started seeing barn fires. And um, I believe that as DDGS was added to swine rations, that's when we started seeing increased methane production and foaming. And I personally believe it the diet made that difference, and the diet matters. So I think that diet, and it goes back to like we were talking about with rumensin, right? So there's things that you could put in diets that can inhibit. There's things that you can put in diets that will increase gas production.
Mhm. Yes, absolutely. And I think my data on that bears that out. We had a lower biochemical methane potential, generally with manures where pigs have been fed DDGs, but they've increased their solids production more than enough to offset the little bit of reduction in biochemical methane. So overall, per liter of manure, the production went up there.
Yeah.
The other thing is, even though we are increasingly precise in our diets, oftentimes that's maybe with phosphorus or nitrogen, and carbon tends to come along for the ride if you can get cheap byproducts that are even less digestible. So I don't know that that always goes just down. And then I guess I'm going to handle one more because we have Randy Sweska, who I have to let his comment through. He was a Robert Burns student as well. He says, "Don't forget deep pit barn slats have a lifetime, which they will need to be replaced, give or take in a few years depending on conditions. Design criteria for collection for biogas needs to account for the serviceability of the slats."
What's That's a great point. What's a typical life, Randy?
We'll see if he unmutes for us. Now he's going to refuse to comment, but probably 20 to
Well,
30 years. There he
I'll,
is.
I'll unmute here. I'm in a situation where I'm looking at some that are 31 years old and they are to the point they need to be replaced. However, some that are also eroded in, say, 15 and 20-year-old barns, if they're not patched or properly repaired, I assume that their service life will be shorter.
So let's say if we have a barn that's got 30-year-old slats and we come in and replace them, what's the remaining life of the remainder of that facility of the pit?
Well, I think pretty good. The old concrete seems to be better than new concrete,
Okay.
and the roof trusses have all been inspected and plated. The roof's new, the rest of the steel's new. The facility's modernized. It's just to the point that the slats are needing replaced.
So that's an intriguing idea because if we when we come up with our solution to modify these barns, that would be the time to do it, wouldn't when we went in and removed the slats, then we could get in and clean that system out. We could um, do what we're going to do, whether it's a sump penetration, a drain penetration, or whether it's to install our manure Roomba or whatever we think the idea is. That gives us an opportunity to come in and do it at that point. And of course, the other question is the let's say that we want to convert a deep pit farm to digestion. Um, would it be feasible to come in and remove those slats? And I guess I don't know how big a cost it is to change the slats, right? Would it make sense to come in and say, the slats have 10 years left, but we're going to take them out and replace them now? Or would it make sense to pull them and try to reset them?
I think it would make more sense, pending the condition of the rest of the structure, to wait until those slats were nearing the end of their life
Okay.
economically. And there is a business that's created a whole model on just slat replacements because barn constructions are out of this world that folks are remodeling old ones, adding service life.
Perfect.
Cool.
So I think that was a lot of great discussion today, and now I'm going to follow up with Randy and see if I can convince him to hang a poultry litter manure belt underneath his pigs to catch the solids on and not the liquid, because I don't know that we're going to make it on Randy's barn to get a digester. We're going to have to move solids around. So we'll have to give that a try. But thank you, everyone, for joining us this season. Thank you, Robert Burns, for finishing it off with a great talk for us. Much appreciated. And hopefully, we'll be in touch with all of you as we get fired up again next year to talk about our emerging science of anaerobic digestion.